All right, let's dive in. In the world of industrial automation, there are some real workhorses, the tools that do the heavy lifting, day in and day out. And today, we're going to talk about one of the most important ones, the count up instruction, or CTU. It's a fundamental building block for any PLC programmer.
You ever stop and think, how does a factory that bottles soda know exactly when a case has 24 bottles? Or how does a packaging line create perfect batches thousands of times a day without a single mistake? Well, it all comes down to a simple but incredibly powerful piece of logic. Let's break down exactly how it works. So here's the game plan. We'll kick things off with what a counter even is, then we'll break down all of its parts. After that, we'll walk through a real-world example, clear up the difference between two critical status bits, and finish up with some pro tips so you can avoid common mistakes.
Okay, first things first. What exactly is this instruction that makes all of this automated counting possible?
So the CTU, the count up instruction, it's really good at one thing, counting up by one. But here's the catch, the really important part, it's when it counts. It doesn't care if a sensor is on for a millisecond or for 10 minutes. It only adds one to its count at the single, precise moment its input goes from off to on, what programmers call a rising edge.
And that one simple rule leads to three super important things you gotta know. First, like we just said, it only counts that false to true transition. Second, it's retentive, which is a huge deal. It means if the power goes out in the factory, the counter remembers its last count when the power comes back on. And finally, it can't reset itself. You have to explicitly tell it when to go back to zero using a totally separate instruction, the reset or RES instruction. All right, to really get this, let's pop the hood and see what's inside. Think of it just like a digital scoreboard, with all the key stats right there for you to see.
Okay, so you've got your preset, that's your target number, right? Your goal. And the accumulator, or ACC, that's your current score. But the real magic happens with these other little status bits. The done bit, the DN, that's your we did it signal. It tells the rest of your program you've hit the target. And the overflow bit, OV, that's your big red warning light. We'll get to that one in a bit.
Okay, enough theory. Let's see this thing in action. We're heading to the factory floor, to a conveyor belt.
So here's the setup. We've got a sensor, and it sees items zipping by on a conveyor. Our job? Make a program that can count out a perfect batch of 5 every single time.
Step 1, super easy. We tell the counter our goal. We set that preset value, the PR, to 5. All right, here we go. The first item passes, click, the accumulator goes to 1. The second, click, now it's 2. We see items 3 and 4 go by, and with each one, the accumulator just keeps on climbing.
So right now, our accumulator is at 4. We're so close. But that all-important done bit, it's still off. We're waiting for that final item. And there it is. The 5th item cruises past the sensor. The accumulator ticks up one more time, and now it's at 5. And this is the moment we've been waiting for, because the accumulator now equals our preset. Bam! The counter's done bit, the DN bit, flips on. That's the signal our whole program has been waiting for.
Now this is where it all comes together in this awesome self-resetting loop. Check it out. The done bit flips on, right? That does two things at the exact same time. It triggers our action, maybe it turns on a light or pushes the batch off the line, and it triggers the reset instruction. That reset slams the accumulator back to 0, which of course turns the done bit right back off. The whole thing happens in a flash, and the system is instantly ready to start counting the next batch. So cool.
Okay, let's talk about those two status bits again, done and overflow. It is absolutely crucial to know the difference, because mixing them up can cause some serious headaches.
Think of it this way. The done bit is your teammate. It's the signal you use all day, every day in your logic. It just says, hey, we hit our number. Time to do the next thing. The overflow bit, though, that's the referee blowing the whistle. It's an error. It's screaming, whoa, you've gone past the absolute maximum number this thing can hold. You use done for your normal process. You use overflow to sound an alarm and figure out what went wrong. And believe me, those limits are real. On some of the older PLC platforms, you top out at just over 32,000. Now, that might sound like a lot, but if you're counting machine cycles 24/7, you could actually hit that. Modern systems, yeah, they go up to over 2 billion, but even that's not infinite, especially if you've got a super high-speed process and you forget to put in a reset. Okay, so now that we know how it works, how do we make sure we use it like a pro? let's go over some of the most common ways people trip up when they're using counters.
You'd think, it's just a counter. How hard can it be? But you'd be surprised. So, what are the classic mistakes?
Okay, number one, by far, is forgetting the reset. Your counter hits its target once, and then it's just stuck there forever. Another huge one is double counting. This happens when you have a bouncy or noisy sensor, and the PLC thinks it saw 2 or 3 items when only one went by. And then there's this really subtle one called a race condition. This is where your reset logic is actually too fast. It zeroes out the counter before the other part of your code even gets a chance to see that the done bit was on. So the action you wanted to happen, well, it never does. It lost the race. So when you boil it all down, it's pretty clear. The count-up instruction, the CTU, it's simple. Yeah, but it is an absolute beast. It's powerful, it's reliable because it's retentive, and it's really the foundation for tracking just about anything in the world of automation. And that kind of leaves you with a cool thought, doesn't it? The elegance of the CTU is that it solves a really complex problem, perfectly batching millions of items with a dead simple rule. It makes you wonder, right? What other amazing, complex things that we see in automation are really just built out of simple, fundamental ideas like this one?